This is lesson 4.6, formalizing relations and functions. Your objective is to determine whether a relation is a function, also to find domain and range and use function notation. Some vocabulary. A relation is any set of ordered pairs. The domain is the possible values for the input of a relation or function. It is also all of the x values. The range is the possible values of the output of a relation or function, or all of the y values. The vertical line test is a method used to determine if a relation is a function or not. If a vertical line passes through a graph more than once, then the graph is not a function. Function notation. To write a rule in function notation, you use the symbol f of x in place of y. A function is a special type of relation in which each value in the domain is paired with exactly one value in the range. For example, identify the domain and range of the relation. Represent the relation with a mapping diagram. Is the relation a function? So here we have our relation, which is a set of ordered pairs in this case. The domain, remember it's all of the x values, so in this case it's -2, 0, 4, and 5. Our range is all of the y values, in this case it's 0.5, 2.5, 6.5, and 2.5. Now we're going to map each element in the domain to each element in the range. So our domain consisted of -2, 0, 4, and 5. You create a little bubble, and you create another bubble with all the range values, which are 0.5, 2.5, and 6.5. We'll map each of the domain values to the corresponding range. So -2 mapped to 0.5, 0 mapped to 2.5, 4 maps to 6.5, and 5 maps to 2.5. Even though 2.5 is repeating in the range, each value in the domain has only one value in the range. So this is a function. If one of the values in the domain, let's say for example 0, mapped to 2.5 and to 0.5, then it is not a function. It is just strictly a relation. Another way to decide if a relation is a function is to analyze the graph of the relation using the vertical line test. If any vertical line passes through the graph more than once, the relation is not a function. If any vertical line passes through the graph only once, then the relation is a function. Problem 2. Is the relation a function? Use the vertical line test. So here we have a relation that has been graphed and it is a circle. The red line here is our vertical line test. So we draw a red line anywhere on the graph and it goes through more than one point. So it goes through this point here and at this point. So since it goes through more than one point, it is not a function, which means that the domain value of 2 relates to +2 and it also relates to -2, so it is not a function. Here we have our parabola. When we draw a vertical line through any point on the graph, the line only goes through one point. So this is a function. So at 1, our domain value of 1 maps to -1. There is nothing else that this x value maps to, so it is a function. We've seen functions represented as equations involving x and y, such as y equals -3x plus 1. We can rewrite this equation using our function notation as f of x equals -3x plus 1. Basically, f of x, that symbol notation, replaces the y variable. You read it as f of x, the function f of x. The letter f is the name of the function, not a variable. Please be careful. Function notation is used to emphasize that the function value, f of x, depends on the independent variable x. Other letters besides f can also be used, such as g and h. Problem 3. The function w of x equals 250 times x represents the number of words w of x, the function w of x, you can read in x minutes. How many words can you read in 8 minutes? So again, we use our function notation. This is the function w of x, meaning our x is the independent variable in the function w, equals 250x. Now we want to figure out how many words you can read in 8 minutes. So we rewrite our function as the function w of 8. So we're saying, what is the function w equal to when x is equal to 8? We rewrite the function part, but this time we substitute 8 for x. So the function w of 8 is equal to 2,000, and we just simplify. We can read this as 2,000 words in 8 minutes. Problem 4, the domain of f of x equals -1.5 times x plus 4 is 1, 2, 3, and 4. What is the range? Notice the domain is written in set notation with the curly brackets. These 4 are the only numbers that are our x values. We want to figure out the range using these domain values. So first you need to make a table, list all the domain values as the x values. Then we write our function as our range to figure out our range, and we substitute for each domain value. So we write f of x is equal to -1.5 times 1 plus 4, and we figure out what our f of x value is, or f of 1 in this case. F of 2 is equal to 1, f of 3 is equal to -0.5, and the function when x equals 4 is equal to -2. So you need to evaluate f of x for each domain value. Then the values of f of x form the range. So this will be our range. And we write our range in set notation with the curly brackets as 2.5, 1, -0.5, and -2. This is the range for this function with a domain of 1, 2, 3, and 4. Identify the domain and range of the relation. Is the relation a function? So again, we can use our mapping to help us out. So we'll draw 2 circles. We'll label this one as our domain, and then this one as our range. And make sure that the domain has only the x values. So let's write in our x values here. So the first x value is 4.2, then we have 5, 7, And we have 4.2 again, so I don't need to repeat that. I can just leave it like that. Our range has values of 1.5, 2.2. Remember, these are all our y values. 4.8 and 0. Now we need to map each domain value to the range. So 4.2 in the first pair maps to 1.5. 5 maps to 2.2. 7 maps to 4.8. And then 4.2 maps to 0 as well. So this is not a function because each value in the domain does not map to one value in the range. 4.2 maps to two different values in the range, so this will not be a function. And if I were to graph this at x equals 4.2, I would have a point at 1.5 and a point at 0, so then it would not pass the vertical line test either. Let's look at number 2. The domain of the function g of x equals 4x minus 12 is 1, 3, 5, and 7. What is the range? So again, we need to create our table. And we will calculate our points. So this will be x. This will be g of x equal to 4x minus 12. So our first domain value is 1. So we do g of 1 equals 4 times 1 minus 12, which equals negative 8. Our second domain value is 3, so the function g, when x equals 3, equals 4 times 3 minus 12, which equals 0. Next domain value is 5, so the function g, when x equals 5, or g of 5, equals 4 times 5 minus 12, which equals 8. And the last one, g of 7, equals 4 times 7 minus 12, which equals 16. So our range values are all our values after we've plugged in the domain into the function. So our range for this problem, range is, and don't forget the set notation with the curly brackets, negative 8, 0, 8, and 16.